Welcome to this scientific lecture on how to calculate calories correctly to achieve weight loss. Today we're going to dive deep into the thermodynamics of human metabolism and energy balance. Let's start with the most fundamental question. What exactly is a calorie? A calorie is simply a unit of energy. Specifically, 1 calorie is the amount of energy needed to raise the temperature of 1 gram of water by 1 degree Celsius. When we talk about food calories, we're actually talking about kilocalories, or capital C calories. 1 food calorie equals 1,000 small c calories. 1 calorie equals 1 kilocalorie equals 1,000 calories. In the International System of Units, energy is measured in joules. 1 calorie equals approximately 4.184 kilojoules. 1 calorie equals 4.184 kilojoules. Now let's talk about the physics that governs weight loss. It all comes down to the first law of thermodynamics. The first law states that energy cannot be created or destroyed, only transformed from one form to another. Change in energy equals heat added minus work done. When we apply this to the human body, we get a simple energy balance equation. Energy in minus energy out equals change in stored energy. If energy in is greater than energy out, you gain weight. The excess energy is stored primarily as adipose tissue, which is fat. If energy in is less than energy out, you lose weight. Your body must mobilize stored energy to make up the deficit. If energy in equals energy out, your weight remains stable. Now let's examine how different macronutrients contribute different amounts of energy. The 3 primary macronutrients are carbohydrates, proteins, and fats. Carbohydrates provide 4 calories per gram. Proteins also provide 4 calories per gram. Fats provide 9 calories per gram, more than twice the energy density of carbohydrates or proteins. Although not a macronutrient, alcohol provides 7 calories per gram and must be accounted for. You might wonder why fats contain more than twice the energy of carbohydrates. Let's examine the chemistry. Fats are more reduced molecules, meaning they have more carbon-hydrogen bonds and fewer carbon-oxygen bonds compared to carbohydrates. Carbon-hydrogen bonds store more chemical potential energy. When these bonds are oxidized during cellular respiration, more energy is released. Compare glucose, a carbohydrate with formula hexacarbon dodecahydride O6, to palmitic acid, a fat with formula C16H32O2. The fat has proportionally far more hydrogen atoms. Now let's learn how to actually calculate the calories in food. The standard method is called the Atwater system. Step 1. You need to know how many grams of carbohydrates, proteins, and fats are in your food. This information is on nutrition labels. Step 2. Multiply the mass of each macronutrient by its caloric value per gram. Step 3. Add up all the contributions to get total calories. Total calories equals 4 times C for carbs, plus 4 times P for protein, plus 9 times F for fat. Let's work through a concrete example. Consider a 28-gram serving of almonds. A 28-gram serving contains 6 grams of carbohydrates, 6 grams of protein, and 14 grams of fat. From carbohydrates, 6 grams times 4 calories per gram equals 24 calories. From protein, 6 grams times 4 equals 24 calories. From fat, 14 grams times 9 equals 126 calories. Total, 24 plus 24 plus 126 equals 174 calories. This matches what you'll find on the nutrition label. Notice that even though almonds contain only 14 grams of fat compared to 12 grams of carbs and protein combined, most of the calories come from fat due to its higher energy density. Now let's discuss the other side of the equation. How many calories your body burns. This is called total daily energy expenditure, or TDEE. Your TDEE consists of 3 main components. First is basal metabolic rate, or BMR. This is the energy required to maintain basic physiological functions at rest. BMR typically accounts for 60 to 75% of your total daily energy expenditure. It includes things like breathing, circulation, cell production, and maintaining body temperature. Second is the thermic effect of food, or TEF. This is the energy required to digest, absorb, and process nutrients. TEF accounts for about 10% of TDEE. Interestingly, protein has a higher thermic effect than carbs or fats. Third is activity energy expenditure. This includes both structured exercise and non-exercise activity, thermogenesis, or NEAT. AEE accounts for 15 to 30% of TDEE, depending on your activity level. To calculate your BMR, we use validated equations. The most accurate is the Mifflin-St. Jeor equation. For men, the equation is BMR equals 10 times W plus 6.2, 5 times H minus 5 times A plus 5. For women, the equation is BMR equals 10 times W plus 6.2, 5 times H minus 5 times A minus 161, where W is weight in kilograms, H is height in centimeters, and A is age in years. Let's calculate BMR for a specific example. A 30-year-old man who weighs 80 kilograms and is 180 centimeters tall. Here are our parameters. 30 years old, 80 kilograms, 180 centimeters. BMR equals 10 times 80 plus 6.2, 5 times 180 minus 5 times 30 plus 5. That's 800 plus 1125 minus 150 plus 5. BMR equals 1780 calories per day. This is just his resting metabolic rate. Now we need to multiply by an activity factor to get TDEE. If sedentary with little or no exercise, multiply BMR by 1.2. If lightly active with exercise 1 to 3 days per week, multiply by 1.375. If moderately active with exercise 3 to 5 days per week, multiply by 1.55. If very active with exercise 6 to 7 days per week, multiply by 1.725. If our subject exercises 3 to 5 days per week, he's moderately active. TDEE equals 1780 times 1.55 equals 2,759 calories per day. Now we arrive at the critical question: how do we create a deficit to lose weight? You may have heard the rule that 3,500 calories equals 1 pound of fat, but is this accurate? 1 pound of fat is approximately 3,500 calories. This calculation assumes 1 pound of pure adipose tissue. However, body fat also contains some water and protein. A deficit of 500 calories per day times 7 days equals 3,500 calories per week, theoretically 1 pound of fat loss. However, reality is more complex. As you lose weight, your BMR decreases because you have less body mass to maintain. Your body also undergoes metabolic adaptation. A safe and sustainable deficit is 500 to 750 calories per day. This should result in 1 to 1.5 pounds of weight loss per week. For our example subject with a TDEE of 2,759 calories, target intake equals 2,759 minus 500 equals 2,259 calories per day for weight loss. Now let's discuss common errors people make when counting calories. These can significantly undermine weight loss efforts. Error number 1. Underestimating portion sizes. Studies show people underestimate portions by 20 to 50%. You might think you're eating 100 grams when you're actually eating 150 grams. That's a 50% error that compounds over time. The solution is to use a digital food scale. Weigh your food until you develop accurate portion size estimation skills. Error number 2. Not counting cooking oils and condiments. These add up quickly. 1 tablespoon of oil is 14 grams times 9 calories per gram equals 126 calories. If you use just 3 tablespoons of oil per day in cooking, that's 378 hidden calories you might not be counting. Error number 3. Trusting restaurant calorie estimates. Research shows restaurant meals can contain 20 to 50% more calories than listed. Error number 4. Not accounting for beverages. Liquid calories are easily forgotten, but count the same as solid food. 1 can of soda contains about 140 calories, all from sugar. A medium latte can contain 190 calories from milk and added sugar. Let's discuss an important concept called the protein leverage hypothesis. This hypothesis suggests that humans eat until they reach a target amount of protein. If protein density in food is low, we overeat total calories. High-protein diets increase satiety hormones like peptide YY and GLP-1, making you feel fuller on fewer calories. Protein has the highest thermic effect. About 25 to 30% of protein calories are burned during digestion, compared to 5 to 10% for carbs and 0 to 3% for fats. For weight loss while preserving muscle mass, aim for 1.6 to 2.2 grams of protein per kilogram of body weight. For our 80 kilogram subject, 80 times 2.0 equals 160 grams of protein per day. 160 grams times 4 calories per gram equals 640 calories from protein. Here's an important nuance. Not all calories listed on labels are fully absorbed by the body. Fiber is listed as a carbohydrate with 4 calories per gram, but humans cannot fully digest fiber. Soluble fiber provides about 2 calories per gram after bacterial fermentation in the colon. Insoluble fiber provides essentially 0 calories as it passes through undigested. This means high-fiber foods have lower effective calories than the label suggests. This is one reason whole foods support weight loss better than processed foods. Let's create a practical full-day meal plan for our 80-kilogram male with a target of 2,260 calories. Breakfast: 80 grams of oats, 100 grams of berries, 28 grams of almonds, and 200 milliliters of milk. Oats: 80 grams equals 304 calories. Berries: 100 grams equals 57 calories. Almonds: 28 grams equals 174 calories. Milk: 200 milliliters equals 122 calories. Breakfast total: 657 calories. Lunch: 150 grams of grilled chicken breast, 200 grams of mixed vegetables, 30 grams of olive oil dressing. Chicken: 150 grams equals 248 calories. Vegetables: 200 grams equals 66 calories. Dressing: 30 grams equals 270 calories. Notice how the dressing has more calories than the chicken. Lunch total: 584 calories. Dinner: 180 grams of salmon, 150 grams of cooked quinoa, 200 grams of broccoli, 10 grams of butter. Salmon: 180 grams equals 374 calories. Quinoa: 150 grams equals 180 calories. Broccoli: 200 grams equals 68 calories. Butter: 10 grams equals 72 calories. Dinner total: 694 calories. Snacks: 150 grams of Greek yogurt and 1 medium apple. Yogurt: 150 grams equals 146 calories. Apple: 182 grams equals 95 calories. Snacks total: 241 calories. Daily total: 657 plus 584 plus 694 plus 241 equals 2,176 calories. This is close to our 2,260 calorie target. This creates a deficit of about 583 calories per day, which should result in approximately 1.2 pounds of fat loss per week. Finally, let's discuss how to monitor your progress and make adjustments. Weigh yourself daily at the same time, preferably in the morning after using the bathroom and before eating. Don't focus on day-to-day fluctuations. Calculate a 7-day moving average of your weight. This smooths out water weight variations. Expect to lose 0.5 to 1.0% of your body weight per week. For an 80-kilogram person, that's 0.4 to 0.8 kilograms per week. If you're losing weight faster than this, increase calories slightly to preserve muscle mass. If you're not losing weight, decrease intake by 100 to 200 calories per day. Your metabolism may have adapted. Reassess your plan every 2 to 4 weeks and adjust based on your results. Let me summarize the key scientific principles we've covered. 1. Weight loss fundamentally requires a caloric deficit based on thermodynamics. 2. Calculate your TDEE using the Mifflin-St. Jeor equation and activity factors. 3. Create a sustainable deficit of 500 to 750 calories per day. 4. Use a food scale to accurately measure portions. This eliminates the largest source of error. 5. Prioritize protein for satiety and muscle preservation, and fiber for improved satiety and gut health. 6. Account for all sources of calories including cooking oils, condiments, and beverages. 7. Monitor progress using a 7-day moving average of daily weights. 8. Be prepared to adjust your plan based on results every 2 to 4 weeks. Remember that consistency over time is more important than day-to-day perfection. Small, daily deficits compound into significant fat loss over months.